Quite often we have information relating a rate of change of a dependent variable with respect to one or more independent variable, and we are interested in discovering the function relating the variable. For example, if we represent the number of people in large population at some time t, then it is reasonable to assume that the rate of change of the population with respect to time depends on the current size of p as well as other factors. The derivative is used in two distinct rules. Number one, to represent the instantaneous rate of change in continuous problem. Number two, to approximate an average rate of change in discrete problem. This modeling method are well widely used in the daily problem as it serves as guidance in solving hand-to-hand modeling problem. In line with ODE, initial value problem can be applied in problem solving using ODE in problems, integrating factor, and other inspection method used. Differential equation can be used to solve problems such as population of infected people, bacterial growth population, and also drug decay problem. Flowchart of modeling process is used as framework in identifying our case study. So this is the flowchart that will be used throughout entire case study. A culture initially has number p0 of the bacteria. At t equal to 1 hour, the number of bacteria is measured to be 3/2 p0. If the rate of growth is proportional to the number of bacteria pt at present time t, determine the time necessary for the number of bacteria to triple. First, the rate of growth is proportional to the number of bacteria. We can write the equation and then can solve this equation by using the separable variable method. We can find the constant A by substituting the initial condition. Then to find the constant K, we can substitute the boundary condition. Lastly, after substituting all the initial and boundary condition, we can get our final equation. To find the time at which the number of bacteria has tripled, we must solve this equation. 3p0 equal to p0 exponent 0.4055 and solve for t. The t is approximately 2.71 hours. Problem number 2. A population of insects in a region will grow at a rate that is proportional to their current population. In the absence of any outside factors, the population will triple in 2 weeks' time. On any given day, there is a net migration into the area of 15 insects and 16 are eaten by the local bird population and 7 die of natural causes. If there are initially 100 insects in the area, will the population survive? If not, when do they die out? The rate of growth is proportional to their current population. We can model the population in the absence of outside factors. Then by using separable variable method, we can solve this problem. To find the constant A, we must apply the initial condition at t equal to 0, the population equal to 100, and we can get the value of A equal to 100. Next, we need to find the constant R. We can apply the boundary condition. We can solve for R, which is equal to ln 3 over 14, and get the full equation of population. Now we will consider the equation of population that include the outside factors such as migration and death of insect. We substitute the value of R from the previous equation. And now we must solve this equation, which is the linear problem. The integrating factor is ln 3 over 14, so solve for the integrating factors. The solution contains another constant C, so we must use the initial condition to find the value for this C. Substitute t equal to 0 and p not equal to 100 into the equation, hence we can solve for C. Lastly, we will get our equation for the population insect growth. Next, we want to determine whether the population of insect will survive or not, so we must determine when the population equal to 0. So solve the equation when population equal to 0, and then we can determine the time. The time of population to survive is around 50 days, hence we can make the plot for this population. The creation of the internet enables users to select and share content which is other electronically, providing new, faster and more decentralized control channel for spreading news. Social media such as Facebook, Twitter, Instagram, YouTube, as well as instant messaging application such as WhatsApp and Telegram that is available in everybody's phones nowadays make one news spread so much wider and faster than 10 years ago. One sensational news will attract thousands of people to be the first to share. Sociologists recognize this as a phenomenon called social diffusion, which is spreading of a piece of information, a technological innovation, or cultural thread among population. In other words, this is how the news became viral. Now we want to model this phenomenon. We will use the flowchart of modeling process throughout the entire process of modeling. Step 1 is identify what is our real problem. So the problem is, how is the spreading of a piece of information, a technological innovation, or a cultural thread among population will occur. Second step is formulate mathematical model. So a few assumptions need to be considered. The first assumption is everybody has the phone and well connected. Second assumption, the content they want to share is interesting enough to make them to share to their friend. And the third assumption, the rate of diffusion is proportional to the number of who have the information times the number yet to receive it. The members of population will be divided into two classes: those who have the information and those who don't. Let n be the number of population, x is the number of individual who has the information, and hence the mathematical modeling will be dx over dt equal to kx multiply n minus x, where t is time and k is positive constant. Now we will solve this model. Since this is separable variable, we can separate the variable. To solve for the constancy, we must consider the initial condition. To solve for the constancy, we must consider the initial condition where t equal to t0 and x equal to x0. So substitute this value into the equation and then we can get the value for c. Substitute our constancy into the solution. And now we can solve for x. To solve for x, we need a few steps in algebraic manipulation. So here, this is our equation for x. Step 4 in modeling process is to interpret the mathematical solution. Now we get the equation for x. From this equation, we can see the equation has the form of logistic curve. That means, as time grows bigger and bigger toward the infinity, the value of x, which is the person who has information, will become larger as much as the number of population, which is n. Last step is to verify the mathematical solution. So what we do now is to find the second derivative. Setting the second derivative equal to 0, now we can compute the maximum rate. To solve for x, the maximum rate will occur at n over 2. So the fastest rate of information will be shared is when x equal to n over 2. Or in other words, when half of population has the information.